When I was about 12 years old, my dad took me in the garden and showed me the planet Mars in the night sky. It was an incredible, sort of exciting moment, and I remember being inspired by that. After that, I really got into astronomy. Even though I hadn't imagined myself as a scientist, here I am, having a great time enjoying what I do. When I was very young and studying maths at school, I didn't really understand sometimes the applications of maths in the real world. But now as a professional scientist, I can see how absolutely vital it is, and it helps us do all sorts of amazing things. I'm Lisa Harvey-Smith, and I work as an astronomer at the CSIRO in Sydney. I'm the project scientist for a new project called ASCAP, the Australian SKA Pathfinder. We're building a giant radio telescope in Western Australia to study the distant secrets of the universe. The Square Kilometre Array is a giant global project being built in 2 countries, in South Africa and also in Australia. This is going to be the most powerful telescope by about 50 times, and much more powerful than anything we've got right now. It will look at the sky not in the visible light that we can see with our eyes, but in radio waves. And these are working together as a team of telescopes to help us to study distant galaxies and stars. Radio telescopes are very different from normal optical telescopes. So instead of just getting the light and bouncing it off a mirror or collecting it with a lens and taking a photograph, we have to do a lot of mathematical things and calculations to actually make a picture with these radio waves. The reason we use a parabolic dish is that the radiation from space is coming in as a plane wave, it's a straight line. And a parabolic dish ensures that all the radiation, when it hits the dish and goes into the focus, travels the same distance. It's a very good way to turn a straight line, a plane wave, into a wave that's created right at the center. If the telescopes are regularly spaced, for example in a square or a rectangular distribution, then there's a lot of redundancy in the array. That is, there are lots of directions and distances that are exactly the same as one another. So we want to avoid this redundancy, and that's why the distribution of the telescopes actually looks quite random. But in fact, there's a lot of mathematics involved in that calculation of how to distribute the telescopes. There's a huge amount of maths in turning radio waves and information from the sky into pictures. The first thing is we use complex numbers. And the radio waves have an amplitude and a phase. There's 2 properties that we're interested in. And if you want to record the amplitude and the phase of the wave at the same time, we use something called complex numbers to actually measure this information. With the SKA, we'll have thousands of radio telescopes spread over thousands of kilometers, and we'll be streaming so much data into our supercomputer, it will be about 10 times more than the current total global internet traffic. So we're talking about computers about 1 million times more powerful than our current desktop computers. So you've heard of megabytes of data and gigabytes. We're currently looking at terabytes and petabytes and even exabytes of data from the telescopes. So we're going to have incredibly powerful computers in the future and very clever software to enable us to extract the science from these data. The ASCAP supercomputer, which is sort of the brain of the telescope, performs about 72 trillion calculations per second, which is another enormous number. Space is absolutely ginormous, and we have to use a lot of big numbers in our work. For example, there are about 70 sextillion stars in our universe. That's a 7 with 22 zeros after it. Maths is an amazing tool, and it's often misunderstood. We know how maths works, but sometimes you can apply it to completely new problems that nobody's ever done before. And that's what we're having to do in these new projects, is to use techniques, use mathematics to answer new questions and to study new phenomena. For example, we can measure radio waves from chemicals in space, and we can use calculus to help us to understand where the chemicals came from. We also use trigonometry in the work that we do in astronomy. It's really a great tool to measure, for example, the distances to stars and help us to understand the structure of the galaxy, the Milky Way that we live in. So imagine you want to measure the distance to a nearby star. What we can do is we can measure the position of the star in the sky, and then we wait 6 months and measure it again. And what happens in that 6 months is that the Earth rotates around the sun. And we know the distance from the Earth to the sun, So that gives us twice that distance, gives us the distance along the side of the triangle. We can measure with our telescopes the angle that the star moves in the sky over those 6 months. And using trigonometry, that gives us the distance to the star.
So what do you think is the best thing about maths?
Well, maths is amazing. I mean, it's a great tool, but it's also quite a personal challenge, isn't it? It's when you're trying to solve an equation, there's a logical way to do it, there's rules. When you get to use it in your career, in your job, you can use it to solve problems, and it can be quite creative as well.
Maths is so much more than a load of equations. It's everything. It's science, it's business, it's finance. It can just take you anywhere. It can take you into so many careers. So it's so important that we understand that maths has a really important place in our world.